Ek kan maar begin hoor.
All right, good afternoon, everyone. Sorry for that short delay. I was watching some things here coming in from management side, so I just had to quickly give that some attention. But here we are now. This is grade 9 coding. It is the 7th of July, and we are programming with the artist, if I'm not mistaken. We are at puzzle 7 to 10. So welcome to the STEM Digital School. I just have to run through a few things before we get started. Is that we need to please respect the chat box, so use it for question and answers only. And then I will also be sharing links with you in that chat box so that you can actually see and do on your own screen what we are doing here. I did receive some feedback after yesterday's lesson. Some of you sent your code through to me, but I'll touch on that shortly. And yes, the videos, please try to keep them off. It doesn't seem to be such a problem in the older classes, so I just want to make mention of that. And then at the same time, the host just covered me because I replanned everything and I never renamed this slide here to the correct date and stuff. So on that note, I just wanted today take the time and give our hosts at Africa Teen Geeks and the STEM Digital School a shout out. Without them, these lessons are not possible. I mean, they come in, they do all the technical setup, they manage everything for us as teachers. We just have to pitch up and teach, and they handle the YouTube upload. So this entire thing won't be possible without them. And from my side, I want to thank all of them. Okay, so let us move on into this today. Here's the same quote that we had yesterday. As you know, I believe that repetition is the mother of all learning. So in 15 years, we'll be teaching programming just like reading and writing and wondering why we didn't do it sooner. This was said by Mark Zuckerberg in 2014 at the Computer Science Education Week hosted by Co.org. So, I mean, this was said in 2014. It's 2020 now, 6 years later, and here we are. We are actually teaching coding in a platform and in a way that we are also teaching English and languages and maths and all the other STEM subjects. So it is definitely something that is happening and that is starting to happen more and more often. And yes, I myself am wondering why this didn't happen sooner, because as I said, I've known and been involved with this for many years before the STEM school came across my path, and I know of other people who has had careers in programming their entire lives. So it is definitely something that is very relevant to our times and to the times and the era that the world is moving into. Okay. So here are some terms that we have to know about. Yesterday we looked at functions and we looked at loops here at the top. So today I want to look at functions again because it's a really important one, but I just want to touch on this sequence because this is something that you hear me say often. I often speak about if we put a sequence here, or first create the sequence and then we test it and then we put it into a loop or into a repeat block so that we are sure that the sequence is fine. So what the sequence actually is it refers to the main logical structure of algorithms and programs. So in our example where we are using the Blockly learning platform on co.org. Blockly is when you have code in those blocks that we have that you can just drag and drop across. So when you combine many of those blocks into a string or an array of things that follow after each other, that is a sequence, okay? And what that sequence is basically a small program in and of itself, even if it is only a small program to make a character in the game do something like move from one place to the next, or if it is the sequence like in some of the online games where you are shooting, what's that one that everyone's playing these days? Ninja streams it so often. I forgot that game's name, but if you know what game I'm referring to, you can type it in the chat box. But there you are running around and they are shooting at one another. Fortnite, that's the one. So each time the character has to trigger the weapon to actually fire, there is a sequence of code behind it that is making that happen. Okay, so now with that idea in mind, you can just imagine, let's say for that weapon to fire is going to take a sequence that is 20 lines of code long, or 20 blocks of code in our example. You do not want to have to each time write those 20 lines of code that you want the weapon to fire, because there are different situations where you are going to use that. Okay, so what you can do is you can create what is known as a function, and a function is a sequence of code that performs a task or calculates a value. So in the example that I'm using, it is to perform a task, and you can call on that function whenever and wherever you need to without having to write the entire sequence again. You define the function in the beginning of your program, you put the sequence in there, you label that function, and then throughout your entire program, you can just call on that function whenever you need to use it. Okay, so that is what a sequence is and how sequences are used inside of functions, and then as well what a function is and how we use that. So this is yesterday's homework. Now, when I didn't actually do this puzzle before I gave it to you as homework recently. I did it a long time ago because I have done this entire course with the grade 4s and the grade 7s before we restarted now. And I remembered that there was something that we had to pay attention to here with regards to this 90 degrees. So what happened is Kwesi actually did the solution, sent it to me. I wasn't home, so I checked it on my cell phone, and he asked me, what should we look at? Because I mentioned in the lesson that we should look at something. And I told him that this 90 degrees should change, but that wasn't actually accurate. What I remembered in my head was that we had to look at this, but it is actually 90 degrees. So in his reply email to me, he said, sir, I tested this code and it is actually 90 degrees. Although it doesn't look like 90 degrees, it is 90 degrees. And then it triggered me to remember, okay, that's exactly what happened when I had the grade 4s and the grade 7s here. When we were creating this sequence, we tried to make this a different degree angle. And if you have a look at the way that the artist is actually approaching this line, it is clear if you turn your head just right, tilt your head just right, that is a 90-degree angle. Okay, so yes, you just had to pay attention to that. And there is a little shout out from me to Kwesi to say, well done, Kwesi. You got it right the first time. And when I argued with you, you stood your ground and you explained your thinking to me. And that is a massive part of coding, right? You need to have the ability to actually, you're welcome. You need to have the ability to collaborate with other people. You need to have the ability to work with other people. Now, along with that, doesn't only come a knowledge of code. There comes a knowledge of approaching people in the right way, having patience when somebody is trying to say something to you and you trying to get your viewpoint across, as well as having the tenacity to take the other person's viewpoint. And that's exactly what Kwesi did yesterday, and that's why I wanted to give him the shout out. Right, so now I think we can jump into today's lesson. So after we've completed the artist work, we are going to start with BB-8 and Ray. Okay, now I am a massive Star Wars fan, so I quite enjoy this lesson, and we don't use the sound in the lessons that I'm teaching because it gives us copyright issues on YouTube. But if you have the sound switched on, BB-8 makes actually a noise that is fun to listen to. Some of the other puzzles I don't want to hear the sounds, but in this one I don't mind at all. So I am going to, yes, Jedi's, cool. So I'm going to jump over to the coding screen and then share the link with you. Let me just get there. You know I like to review, so I just want to check what puzzle 7 was. I think that was, okay. So this one we did in class yesterday. I'm not going to touch on that again. I want to touch on the one that we did for homework again. There we are. This is this one. Right. So come on, just copy this properly and then drop it into the chat box for you. And then as you head over to the chat box, I'm going to start explaining, and you can open the link in front of you. So if we have any new students here, I see you guys rename yourselves often. So I'm not always sure if we have students here for the first time or if we have repeat students. But for those of you that are here that have been with us before, we hope you enjoy this and that you are actually learning something from this. And then for those of you that are new, I have to do a very quick run through of the graphical user interface. So the user interface is what we see here. We call it a graphical user interface because we have graphics that are displaying the things that our human eyes and minds like to process. The computer itself doesn't need the graphics, but they are there for us to interact with the computer software and the computer hardware, the systems of the computer. Right, so here at the top, we have the lesson that we are on. And if you click on that, you can actually access all the other lessons. So if you keep the link in your browser open after we all leave the Zoom meeting, then you should have access to the other puzzles if you'd like to do them. These are the puzzles that are under this lesson. So we've completed all of those ones. The white ones are still to come. So here on the left is the play area where we see the code happen. This is where we find the blocks of code that we will use. So this is our toolbox, and this is our workspace where we create the code that is going to be acted out there. And these are the instructions that will tell us what we have to do and how to do it. It does not, however, explain why, and that is why we are in this lesson together, so that we can dive into it deeper and help each other understand it more. So here we have a run button, which is connected to the when run block. When we click on that, all code that is connected to this block will activate. And here's a skip puzzle because it is a challenge puzzle. So if you said, yes, I'm ready for the challenge, and you see the challenge seems too big for you, then you can skip it. And here we have a slider where we can adjust the speed. So if we want to see in more detail what happens, we put it there. If we're running the code for the 4th time because we just quickly went back to discuss something, we can speed it up. And here at the bottom, there are some videos. If you want to watch that, we don't do it in lessons, again, for the copyright issues that we might have. So let us start with this. What we have here is we have this name tag for a pet. And it says this tag is a special one. Can you figure out how to draw the outline? So our job is to create the outline here. We're limited to 12 blocks, okay? So they're telling us that the long side, so that's from there to there, is 150 pixels long. So we discussed this yesterday. Pixels is how we measure distance on a computer. Excuse me, on a computer's display at least. And then all of the short sides are 75 pixels. What they don't give us are these angles, so we need to figure that out. So let's just do the obvious, easiest thing to do, and that is to draw that line at the top there, because our artist is already facing that way, so we only need one block to complete that. So here we just need to understand the difference between the jump block and the move block. If we place a move block, the artist will draw a line. If we place a jump block, the artist will still move from one point to the next, but not actually draw the physical line. And here you can click on this and change it to 150 pixels because that's what they told us how long it is. It's 150, and there we go. So that's done. Now we need to figure out that he has to turn, and we need to find which way we want him to turn. So if we accidentally put a turn left there, this is going to be a turn right. But you can just adjust the toggle. You don't have to delete the block and then put it back. And this is, if you look at the degrees, you can see here what the degrees are going to be. No problem. There's the link to you. So here are the 3 options that we have, and there you can see what the degree is going to look like. And this is where the confusion comes in with that next corner. But for now, this is going to be a 45-degree angle. Now, before we place the next line, we can test this because you'll see the artist turn. And when he turns, you can see which direction he's facing. So it stands to reason if he's facing the right direction, and we place this one there and we set it to 75 pixels because that's how long those sides are, as was indicated to us here in the instructions. Now it will draw that line, or he will draw that line. Now that we're there, we need to turn to face this way. So this is where you can start to test. If you are uncertain, you can drop this in here, set it to 45, run, and you'll see Okay, now he's facing down. So that's obviously not enough. Then you can set it to 90 degrees and you can run it again. And now you can see, okay, he is facing the right direction. If you are still uncertain, maybe you can't completely see his orientation, change this to 120, run it again, and then you will see, okay, he still seems to be facing the right direction. So let's test that. Let's add a move forward, and we put this by 75 degrees. And now when we run it, we'll actually see that 120 is too much of a turn, right? But if we remove this move forward and you just look at the way that he's orientated, he almost looks like he's lined up there. So again, you can test it, always test it. And that's what I said about these degrees. They tend to get me, they catch me out very often. But when I'm sitting here on the coding platform, or when I'm writing code for a website or something, I don't often use degrees, but let's say I was, then I could just test it and see what will happen, and I can figure it out that way. Okay. So now we know 90 degrees is the correct one. We can add that move forward back. Now when we run it, we can see that this is a sequence of code. Remember we spoke about sequences earlier? There is a sequence of code, and what that sequence has done is now completed half of our tag, our pet's name tag. So what we can do is actually turn him again, and we will have to turn him again if I'm not mistaken. So let's just do that before we do something else. I think it's going to be 45. Let's run it and see. Yes, that's fine. So now that we have him here, we can actually create this entire sequence of code again, but I don't think we'll have enough space. So the only thing we really need to do is to set this repeat, and remember to toggle the amount of times you want the loop to run. If you do not toggle that, then it is not going to work, okay? If you have it on the question marks, I can't, then it'll give you an error here at the top. And now we can test it, but you can see that we're testing it and we stuck the sequence into the loop after we've identified that the sequence is correct. If we were to try and figure out this degree here, this one where I had the trouble with, if we were to try and figure that out while this was in a loop and it was set too fast, it becomes extremely difficult to do that. But because we tested the sequence and identified that this solution works, and then we stuck it into a repeat, it was a lot easier to do it that way. If you'd like, you can set this to a different color. This is all up to you. There is no wrong or right here. I'm just going to make it blue because that's an easy one to choose. Okay, so does all of this make sense? Type a yes in the chat box if you're happy with it so that we can continue. If you do not understand, please type no. I do not mind repeating puzzles if we have to. These are the foundation, guys. We need to understand these repeats and these loops really, really deeply and solidly, and have practiced it many times, because we're going to move into conditional repeats, and they are a lot more difficult to figure out than these normal repeats are. Okay. So here we faced one more tag. This is a triangle for pi or p. I don't know how you pronounce that. You can choose. I prefer pi. And it's telling us that each side is 150 pixels long. So just to drop the link in case someone enters a little bit late, and to help me navigate the chat box. So 150 pixels, we can already see he is facing the right way. So we can just set that to 150 and test it if you'd like. Okay. Now where we do have to start testing is with the turn and the degrees. So obviously we'll be turning left because we want to go up. And now we can see, well, there are only two options. 90 degrees obviously will not work. So it has to be 120. And you can check that it works. And now you can either create this 3 times more, or you can drop it into a repeat block and tell the repeat block this time to repeat 3 times. Okay, so this is going to loop the sequence inside it 3 times. And when we run it, we can see that it is correct. Again, if you'd like, you can set the color because you have block left, you have block space left. And this time I want it orange. So Again, that's not a prerequisite. It doesn't change whether you reach the goal or not, but it is good for us to practice alternatives. Are you all happy with this one? It's also pretty straightforward. Can we continue? Good. Okay, so these that we see here on the screen now, they're basically here to help us practice and to help us better our debugging skills, right? So a big part of debugging is having the ability to read code. You won't always have the ability to run and test it necessarily. You are going to run it and you'll see there's a mistake, but for you to find that mistake, you need to be able to read the code. So, or you can use the comment technique, and I'll teach that to you when we get there, but for now, just focus on reading it, okay? So look carefully at the code below. What will happen when you click run? So the artist will draw, excuse me, the artist will draw a triangle with 3 equal sides. So if we have a look at this, we see there's a 1, 2, 3, 4 move forward. So drawing a triangle, I highly doubt it because we have 4 and a triangle has 3 sides. So we can already see 4 will be drawn. So using the process of elimination, we can already say that that one will not suffice. The second one is the artist will draw a single line. Again, we can see 4 lines being drawn, so that one by process of elimination is gone already. The C is saying the artist will draw a square. Now this can be reasonable because you can see there are 90-degree turns there. Okay, 1, 2, 3 of them. So I'm not too sure. And there are 4 lines there, right? So we need to determine, we know that a square has 90-degree turns, we know that a square has 4 sides, but now usually a square has 4 corners. So let's look at what our other options are. I don't know. So that one is never allowed to be chosen because we are coders, so we have to fix the problem and find the answer. We cannot say we don't know. So just to explain this to you, the answer is C. Yes, you are correct. The code is only, just review this, the code is only making him turn 1, 2, 3 times. This last corner is being created by where he started and where he finished. So there doesn't have to be a turn left by 90 degrees in the sequence of code to create that corner. That corner is created because of where he started and where he finishes. Okay. So we saw 3 90 degrees here, but the square still has 4 90-degree angles. Are you all happy with this? Can we move on? Oh, come on. So let us get going here. Continue. Okay, so here are 2 bonus levels. You need to choose one. Type in the chat box left or right and we'll see which one we're going to do. So there's one for left. Going to give 5 more seconds. Check if anyone is answering. Another one for left. Okay, that's enough. 2 for left. We'll go with that. Right, so we hope this would be a little bit complicated. I guess that's why everyone chose the left one, because the other one looked too easy. But the roof has already been drawn, so we just have to do 2 squares. Draw rooms for each of the animals. There are many different ways to solve this puzzle, so have some fun. Each square has a side length of 100 pixels. So We're facing this one. Now, there are two ways just off the top of my head that we can do this. We can either draw one square, then jump and draw one square again, which I think is going to be the way that I would prefer to do it. Or we can draw the entire rectangle, then jump and draw that line. So I think let us start by drawing one square by one square, and I'll show you why. So we can move forward. We're going to turn right, obviously. So we're coming down this way. Move forward again, turn right again. Okay, now we're here, there. So now we have actually two lines, but we can repeat that twice. And if we run that, we are going to have that. Okay, so that's good. Now that we're there, we can jump forward by 100 to place us here. Let me show you that. Now we can see that if we repeat this code, we can draw the next square as well. Two ways to do it. Either we create this entire sequence, including the repeat again, or we can place this entire thing into a repeat. Look at that. This is what's known as a nested loop. Now, we haven't touched on this yet, so this is an introduction to that. But a nested loop just means a loop inside a loop. Okay? And this is going to jump forward, but we need to have the jump forward inside so that it can happen again. If we put this after this, then the jump forward is only going to happen after this has happened 4 times, because now this sequence is running twice for that repeat. Then this entire sequence is running 2 more times for that repeat. So this entire sequence will run 2 times 2, 4 times, right? So if we place the jump after this big repeat, the first repeat, then actually the one that will happen second, the second repeat, then we are going to just go in over the square. So there we've done it twice. Now we're doing it again. And then we jump to where we want to be, which is not ideal. What we want to do is we want to actually put this after the first repeat. So this is for the first square. Now we don't have comments. So if I had a comment, I would have entered that in there. But for now, let's just leave it as it is. So there he's jumping, and there he's doing that again. Okay. So what we actually can see here is now that we've used 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 blocks. Okay. But there is some code that is repeating over itself. Okay. So we can see, I'm just going to speed it up until we get to that point. Right. So there we have 1, 2, 3. So the 4th time, just show you here, this line gets drawn twice, and this is jumping forward again. Now that doesn't really make a difference unless if we add a set color in here. Let's do it that way. So if we add set color in here and we change it to a color that's easy to see, red is fine. Now when we run this, what's going to happen is after the first time, it's setting the color to red, jumping, but now we're going to be covering this in a red line. Can you see that? Okay. Right? So if everything just remains the same color, you won't see that happening. But if you change the color and you use this method, that line is going to be different. Okay. Now, there isn't a right or wrong. It's just to illustrate to you why or how some of the code is actually repeating. Okay, so this last move forward and turn right and this jump forward is actually a waste. But if we take into account, if we would have done this, let's remove the set color. We would have used 1, 2, 3, 4, 5, 6 blocks. Then we would have done these 1, 2, 3, 4, 5 again underneath here if we didn't nest this loop. So then we would have used 6 plus 5 would have been 11 blocks. Okay. So now we need to determine by ourselves. If we really have to change this color and only have those 3 a different color, then it might be worth using the 11 blocks. But because it doesn't make a difference to us and we're nesting this, so we're only using 7 blocks of code, we're wasting 3, but we are saving from 11 to 7. So we're saving 4 blocks in code that has to run. Okay, so even though some code is running twice unnecessarily, we are still using less blocks than we would have if we didn't use the nested repeat or the nested loop. Does that make sense to you? Are you all happy with that? Okay. I'm not going to jump into doing this in a different way, solving this in a different way, because I want to get going with the next lesson. Lesson 6. I'll continue. You can watch the video on your own time if you'd like to. Right, so this is our introduction. It's extremely easy. Go get the scrap metal BB8. Use 5 of the same blocks to get the scrap metal. Scrap metal glows like this. Okay? So there we can see there are 1, 2, 3 scrap metals there, and they glow every once in a while. You can see them illuminate and then it goes away. So for us to collect scrap metal in this, there is no, like we had with the collector with the gems. Just share this link again, just in case. Come on. My Zoom controls are hidden away up there where the link is at so that it's not in my way. And then when I want to copy the link, it does get in the way. Anyway, when we did the collector, there was a collect block. For this, BB8 only has to move over the scrap metal to pick it up. There you can see. Okay, so he doesn't have to actually do anything specific. So 2 ways we are allowed to do this because of the restrictions in the block. So you can either place 5, move forwards, 1, 2, 3, 4, 5, and we'll move all the way to the end, picking up all the scrap metal on the way. Or we can do, as James has said in our chat, you can just move forward in a repeat 5 times. Okay. Now, I would prefer for you to use a repeat wherever you can because we are practicing loops. Okay, so every time or everywhere in any of these puzzles that it is available and it's possible, we try to use repeats. Okay, can I continue? This one's pretty easy. Okay, good. Let us continue. Okay, so here is another one, excuse me, of those debugging things, but what they're actually doing here is we're just smarter than they are. They wanted us to use 5 move forwards and then they'll show us this and ask us if it's going to do the same thing. So we already know what will happen here. BB8 will move 5 times and get all of the scrap metal. So we're not going to waste time on this. Just select C and carry on, skip the video, and then we are now at this one. So I'm going to share this link to you. And you will be very surprised to find out that you are going to tell me what to do here. Bear in mind, we are restricted to 3 blocks, of which 1 is already used. So we can only add 2 more blocks. And here's another thing that's new. We only have 1 move forward block available in our toolbox. When we use 1, you'll see there's 0. And when we add that, it gives us that little mark that's shouting at us. Okay, turn left. Now, just as a word of advice, he's facing up already. He's not facing this way. He's actually looking up. I understand why you said that because it's difficult to see. I just know he's facing up because I've done this before. So if we place 1 move forward, you'll see he's already going in that direction. He's not facing towards the workspace. So 2 blocks that we need to make him do all of this. Which 2 do we need? There we go. Exactly the same solution as we had earlier. Rocket science, right? Extremely difficult. Can we continue? Let's see if we can fit in one more before we have to end this lesson. Yes, I also think so. Okay, now it gets a little bit more tricky. In this puzzle, 2 repeat loops will help you get BB8 to all of the scrap metal with the fewest number of blocks. Again, we only have 2 move forwards to use. Earlier, we only had 1. But it's going to be up to you to tell me what to do here. We have a restriction of 6 blocks. Any ideas? Okay. James says repeat move forward times 4. Just want to check. So we are going to add a repeat block, add a move forward in there, change that to 4. Come on. There we go. Because we have to move 1, 2, 3, 4 ahead. Now we didn't have to test the move forward before we put it into repeat because just moving forward is easy enough to understand. Only when we want to repeat bigger sequences that it's advisable to test them before we actually move forward. I'm lying, before we actually put them in a repeat. Right, so what's next? Turn right and move forward times 5. So my question is, this turn right, where does it go? Under move forward or under the repeat times 4? Where does it need to be? There or there? Which one? Under the repeat, yes. Because if we put it in the repeat and obviously change it to turn right, then he's going to move forward once, then turn right, and he's going to start going in a square. Look, see? Okay. So this has to be under that so that he first does that, then does this. Then we're going to repeat and move forward again times 5 because we are now facing the correct way. Standing there, we want to move 1, 2, 3, 4, 5. Okay. So what I want to do is I'm going to leave you guys with a link. And it's going to be this one. You have 5 blocks to get BB8 to get all the scrap metal. Just paste that in there, right? This is going to be a homework exercise, so you can send it to me via email. I'd appreciate that. I have to jump a little bit 2 minutes early today because I have to arrange some things for another lesson. But that was, tomorrow we are going to, obviously I plan to do 5 to 11. We're already at 7. So we can actually see if we can finish this tomorrow. What's tomorrow? Wednesday. Yes, that would be good. If we finish this tomorrow, then we can start with lesson 7 on Thursday and devote Thursday and Friday to lesson 7 because I think we should be able to finish that at that time. All right. So you have that link. Please feel free to send me any additional questions. Oh no, I opened the chat box hugely. To send me any additional questions or to send me your feedback and the code that you have created. I'm sorry for having to jump off a few minutes early today, but I think we got a lot done. And yes, there's my email address. You can find us on these social media channels. Just search for Africa Team Geeks on Facebook, Instagram, or Twitter. Thank you so much, guys. I'll see you tomorrow. And please invite your friends to come and join us in this lesson if you find it fun and you think they'd enjoy it as well. All right, goodbye.